So with that, please help me to welcome Gábor.
Cool, thanks. Thanks. I would like to extend thanking MRCs for hosting this event. This is actually my first time in this meetup space. It's pretty nice, I have to say. There's air, all of us fit, and we have a nice group of people. So I'm very excited to give you this talk. And I realize there are going to be 2 amazing talks today after mine. So I'm going to try to keep it short, and I'm going to try to keep it high level, understandable, and really something that you want to hear on a Wednesday evening. All right, so let's get into it. Title of my talk was Cluster Managers, Orchestrators, and Schedulers, and Do I Need One? Now this is totally a title that was meant to attract all of you to come here, because there's so many buzzwords and so many words that I have no clue what they really mean are in the title, that it clearly worked, so you'll all hear. So I will definitely talk about those topics. My name is Gábor Rátky. Thank you for the introduction. I'm the CTO at Secret Sauce. We're very far from here. We're down the street, about 2 minutes away. We are a Silicon Valley-based startup here in Budapest, working in the fashion industry. If you're interested in us, check out our website. All right, so books usually end with glossaries and with explanations of the words, but I think the title of the presentation does deserve some explanation. So I kind of looked up what cluster manager means, and cluster manager, nothing else but software that manages more than one computer. If you look at orchestration, that sounds a little bit more complex. It even has the word complex in it: automated arrangement, coordination, and management of complex computer systems, middleware, and services. Still no clue what exactly that means, but it sounds very complicated. And then scheduling. Maybe scheduling's the most straightforward. Scheduling deals with where work should be performed. If I have one machine, it's pretty clear where that work will be performed. If I have more than one machines, and if I have a cluster, I have more than one machines, hopefully, then scheduling can really determine where the work should be performed according to some criteria. And then some criteria is very vague. It can be anything. It can be random. It can be, there can be many strategies. And then one word that I do want to clarify, although I didn't put in the title, was automation. Sort of what do we mean? Because these concepts, automation and orchestration, are sometimes mixed up. I believe that that's the easiest way to go about automation. It's really just ensuring that we have a task, and we can repeatedly perform that task without minimal input and hopefully without human intervention. So I actually worked at a bank where we had the project manager stop processes and start processes when there was a new version. So that that's not really automating that needs people. So that's kind of what we want to avoid. And of course, when it comes to cluster managers and all these tools, there's a lot of automation involved. Now, we finally know what all those words mean. So really the question then becomes, do I need one? So how do you guys feel about it? Do you need one? Do you need a cluster manager that can manage many computers, orchestration, scheduling, all of those things? Do you think you need one? Yes, no, maybe, it depends.
Yes.
Okay, he needs one. Who else needs one? All right. So no, you don't need one. The point is that by default, by really clarifying what you want to do, you really don't need one. Like, God, no. Please don't use a cluster manager because it sounds exciting and it sounds like this is the new thing, and like there's somebody mentioned Docker, microservices, and then cluster manager, so cluster manager must be awesome. Like, please don't. Please try to avoid at all costs to use some of these softwares. I could have also asked you, if you look at the definitions, I have words like complex, automated, arrangement, coordination. If I ask you, do you want your system to be more complex, you would have said no. And the point I'm trying to make here is that don't make your system more complex if you don't have a reason. And that's actually the first part that I want to talk about, because I want to talk about the complexity monster. Does someone actually recognize this photo from somewhere? Has anybody ever seen this photo? This is actually not the complexity monster, but I really like this photo, so I put it in my slide. All right, no problem. So this is the panic monster, different kind of monster, but there's a really, really interesting article about procrastination. All of us are procrastinators, or actually a lot of us are. I'm definitely one of those. So really cool article and cool photo. probably done in MS Paint. All right, so I'm going to talk about complexity first, and then we'll get into the actual pieces of software that you've all come for. All right, so let's imagine that there's the y-axis, and the higher you go, the more complex something is. Now, complexity does not really have a unit, right? It's like that. It's like not 2 complexity or 3. It doesn't have a unit of measurement, but you can think of like it is complex to maintain. Is it complex to understand? Is it complex to explain? And often we software engineers and sysadmins are at fault of having a problem, that tall, that's the problem, and then we come up with a solution, and then the solution overarches the problem, and sort of the solution is a lot more complex essentially than the problem. Does anyone have a word for this? Like, oh, this looks like X. This is exactly over-engineering. Thank you, guys. You're still following. That's great. All right. So yes, this is over-engineering, and you can actually take this further. And I really, really like this concept that I'm about to explain. This is one of the first things I always explain if somebody joins our team. When you create an over-engineered solution, there's actually 2 parts to it. There is the part that solves the problem, right? Like you need that level of complexity because you have a problem. It's like you cannot avoid the complexity of the problem. And this is called essential complexity. This is good. Like you need to maintain this. You need to be able to solve the problem. But then you have the big red on the top, which is called accidental complexity. Like, oops, accidentally I engineered something more complex. And whenever you see that, you want to get rid of that. You want to get rid of that. But even more importantly, you never want to bring on accidental complexity. Cluster managers, orchestration, scheduling, they're full of accidental complexity if you don't have a problem to solve. And I'll talk about some of the problems that these tools solve, but you've been solving those problems. And we've solved those problems well before there was orchestration, and there was all this software that we talk about nowadays. Anyways, let's say we can get rid of that accidental complexity. There's another thing that can happen. Let's imagine that we've been maintaining this solution, and we realize that there's a better way to do it. There's maybe with some refactoring or replacing one tool with another, we can actually reduce the complexity of the problem. Now, it's actually simpler to understand, to explain, to maintain. Maybe there's even less lines of code, so I can even measure it. And then there's this yellow part. And the yellow part was once very important because it was our essential complexity. It solved the problem. But now it's there, and we know we shouldn't be maintaining it. We shouldn't be dealing with it, right? Like if there's something goes on with it, we have to deal with it. Does anybody have a word for that? Yeah, maybe. Yellow box. It's called technical debt, and I'm sure all of you know the expression. You want to get rid of it. Like you want to get rid of the software you don't need anymore. You want to get rid of the process you don't need anymore, the task, all of those things. So you get rid of that. Oops. You get rid of that. You have the simplest solution. And the worst of all, and all of us, I wouldn't talk about you guys, but I'm definitely at fault here. I don't know every one of you, but I'm definitely made this mistake. What is the favorite, right? Like a solution in looking for a problem, right? Like, let's use Docker. Okay. And what's your problem? No. I know the solution. Let's use Docker. It's like, okay, but what is your problem that you're trying to solve? It's like, okay, now I package my application into Docker. It's like, okay, so let's say now you have to deploy it. Now you just made things harder on yourself because Docker doesn't give you anything. It's the accidental complexity unless you're actually solving a problem. So this is, by all means, we should avoid this. And the way to avoid this when the solution is a cluster manager is not to use one, right? Like how many of you run, let's say, a web application, Rails, Django, whatever, like your typical stack on a single or 2 machines load balance, right? Like you have an application like that, like or at least you used to have. Like now maybe everyone's in the enterprise and okay. So you definitely have that. You don't want the complexity of all what I'm about to talk when you're dealing with simple problems, right? And then let's see some of the problems. Like really the question we should now be asking is like, the question is not whether I need a cluster manager, whether I need Kubernetes or Nomad or Docker Swarm, but really, what problem do I have? So you could say, by the way, what problem do you think these software solves? Just words. Throw out some words. See if we can find some of those on my slides as well. Scaling? Okay, I don't have that, sorry. Good point, though. Scheduling, okay. I don't have that either. Okay, that we're getting somewhere. All right, I have a totally different set of lists, but I'm going to go through anyways. Okay, so these you can deploy with these pieces of software, but you shouldn't be using a cluster manager just because you're trying to solve a deployment problem. That has been solved, in many ways for 20 years. You had Capistrano, you had Puppet deploying application, you have Amazon Code Deploy, and this is going to sound like crazy, but there's Git push to Heroku. That's deployment too. And like the essential complexity of Heroku is 0. It's you sign up and then you push, and then your application is running. And if that's all the complexity you need to solve, then of course Heroku is a good choice for you. I believe we're at Emarsys. Emarsys runs software on Heroku, right? So we've been running for ages, and then we had problems like the Emarsys guys had, where how do you talk to a MongoDB cluster over the public internet, or how do you talk between services on the public internet? Maybe it would be nice if it was together. Anyway, so deployment out. All right, high availability, right? As if there was no highly available software before cluster managers and these pieces of software. All of us configured load balancers, or had Amazon configure for them, or had Heroku configure for us, or just write an HA proxy configuration, or even let the configuration management software write that file. So again, this is not a new thing. Same goes. Actually, service discovery is my favorite. That's a problem, right? We now have all these services, and they need to discover each other. That's a problem we created for ourselves, because now we have no clue where each piece of our software is running. When we started SSP, which was 6 years ago, so it wasn't a long time ago, we had API 1, API 2. I totally knew where the software was running. I didn't need to discover it. And then maybe I brought in a new server, and then some configuration needed to be updated. I mean, there is the point where it's still okay to manage those, and then even manually. There are company sizes, there are problems that are just fine, and then once it gets out of hand, once it becomes a problem, then you can either rely on other companies and then spend a shitload of money on that, or come up with something. And that brings me to the most important piece, which I don't believe that we have solved before, and that these pieces of software do solve, is utilization. I have a computer, whether that's a hardware or a virtual machine running in Amazon, GC, wherever, and it's sitting idle. And that costs me money. Cost is a huge issue when you're not utilizing your computer. It means that, hey, Amazon, please take my money. And that's it every single month. I see those emails when the invoice comes, and I'm crying because I'm spending so much money on servers that are not doing anything. That I have my little proxy server running one process, and then every second week somebody actually opens a website that needs a proxy to the US. So money, money, money. And I'll actually show you that this is a huge problem. I queried this today. Our average CPU utilization is 11% in our production environment. This is the last 30 days. I'm extremely proud of that number, which means that I'm spending $100 and I'm getting $11 value out. I'm extremely proud because the industry average is under 10%. Now the crazy part is, by the way, who has some idea what their utilization is? I'm just curious. I had no clue before I looked at it. I was guessing that it was, yeah. If I included non-production environments, all the machines that are just small machines sitting idle, 6%. I almost cried. So Google, and all these internet giants are actually running at 40, and Google is actually running at 60%. That 60% means that if I take my SSP 11% and I bump it up to 60%, I'm spending 6 times less money. So if I spend $12,000 a month, then I'll be spending $2,000 a month. And I'm obviously simplifying, but that money is your salary, your future employee salary, who we're not going to be able to hire because we're spending all this money on infrastructure. So once you hit issues with your cost, and I know Prezi did, and maybe MRCs did as well, then you need to solve these problems. Until then, just do your thing. All right. So, and then I need to have a slide about containers, because and then, you know, the photo is actually Docker, but in containers in general, that first, we had the same problem before. I probably wasn't dealing with the problem because I was too young, but when virtualization came about, the same problem. I have a big bare metal hardware, and I want to slice it up and be able to utilize it better because I spend like $10,000 paying HP or IBM. Now, the story is slightly different. We're running on virtual machines, and now we want to utilize everything that the virtual machine has. And containers, and not really just, like not containers, but the image, the tooling, the APIs, the way we can share those, are finally something where we all agree how an application looks like. It doesn't matter if it's a Python application, a Rails application, or God forbid a Java application. It looks all the same. So any tooling you build around it, whether that's about log aggregation, whether that's about scheduling, or you know, health checks, or these things, they're all going to look the same. And that's really, really important, because if you look at Kubernetes, if you look at Nomad, they deal with some sort of concept like a container. All right. Any questions about the first part? I know I was like trying to move a little bit fast. If not, then you'll have a chance at the end. All right. So if you actually have to solve the problem that, for instance, we are facing, we are facing this problem today. And by the way, I forgot to mention, but Tommy was doing a lot of research around these pieces of software, so I'm totally stealing his notes. But we have this problem. Today, we are spending too much money on infrastructure that we are not using. And it is a problem because we're not this big ass company that doesn't care how much we spend, but we actually need to reduce that. All right. So when it comes to containers, I want to show you one very quick visualization of how you know, deployment could look like in the old world and how deployment can look like in the new world. So if this actually worked, oops, maybe it doesn't. Okay, it doesn't. Okay, and I'm running out of time. So actually, Tetris is a great example of how scheduling could work. If all you did, you just dropped your little pieces with a single button, you could call that one-click deployment, right? You have like a row, which sort of represents your infrastructure, and you're just putting pieces on top of each other. This really annoys me. I really want to show you. Yep, there you go. So one-click deployment in action looks like this. 3, 2, 1. Let's deploy, I don't know, Capistrano, Jenkins, manually, code deploy, all right? And then every row is a machine, and I'm not really utilizing the rest, right? I have these different shapes, different memory usage, different CPU usage, and they all have all the space in the world, so they can run clearly. But now I ran out of time, ran out of space, right? I need to buy more machines, I hire less people, or I spend less on the summer party. Now, bin packing, which is a feature of all these schedulers, is that, oh, maybe I'll schedule it here, and then I'll schedule it here, and then you've all played Tetris. And essentially, there's the scheduler working, really figuring out, maybe vertically is the memory usage, and horizontally is the CPU usage, and then, it might actually do that, right? It's like, oh my God, I'm only utilizing 90% of my compute. That's probably fine. So anyways, bin packing, the feature that actually takes the different tasks and schedules them next to each other, is like Tetris, right? And actually, you can go a lot further with the same area, which represents our money, if you're actually doing this bin packing. Cool. I got to play Tetris during a live presentation. All right. So keep that in mind, and really that's the killer feature, I believe. All right. So Docker Swarm. I'm going to talk about 3. I'm going to talk about Docker Swarm. I'm going to talk about Nomad, and I'm going to talk about Kubernetes. These are the ones we looked at. There are a lot more. I'll have a list, and I'll have some comments for those, but slides I only have for these, and time I only have for these. So Docker Swarm. How many of you heard actually not heard, but saw the DockerCon keynote the first day? Okay. So it was pretty cool. I recommend you to watch it, because 1.12 Docker has all the features that you need that we talked about. It has service discovery, it can really manage a whole cluster of computers with the exact same tools that you've been using. By the way, how many of you have used Docker, not necessarily in production, but kind of looked at it, have an idea? Okay, very cool. I'm not going to talk about Docker today, but definitely an enabler. You definitely need Docker for Docker Swarm, and you definitely need Docker or some similar technology for the rest. All right. Developed by Docker Inc., so the company itself. So Docker, the company raised hundreds of millions of dollars, and now they really have to figure out how they're going to actually make money so that they can pay back their investors, threefold or fourfold. And of course, they're building a lot of open source tooling, and then they're building things like Docker Cloud and support and all that. So it's the official company behind Docker. It's multi-host, multi-container orchestration. So far you could run containers on one machine and maybe write it, link them, but it had to be on the same machine. Now Docker, with the exact same API, the exact same commands, you can say that I want to run these 3 containers. I don't care which machine they're running, and they should be able to talk to each other. And it solves the networking for you. It does the routing. The containers, it will feel like they're on the same machine. And that's exactly what we want to achieve. We don't want to think about machines anymore. We just want to think about concepts like service or concepts like node. All right. It doesn't matter that it's Raft consensus, but the important piece is that Docker Swarm has built-in state. So it solves that for you. So you need an external state. Distributed state store like Zookeeper or etcd. Docker is really, batteries included. That's how they call it. So I've already mentioned does the routing mesh service discovery. So very typical DNS, and then it can actually point you to the right places. And there's actually a private beta going on to integrate Docker and the whole Docker cluster into service providers like AWS. Why is that interesting? Well, you do want to be able to access these applications from the outside as well. So maybe you create a service, you want to have a load balancer in front of it that Amazon gives you. Or maybe you're running out of capacity, you want Amazon to be able to start a new instance. And these are some of the problems that all of the vendors are trying to solve now. So Docker is definitely moving in this space. By the way, the fact that they have $200+ million means that there's probably 500 engineers working on these problems. And they're really the standard. So they're in a really good position, but it's very early. The announcement was a month ago. There's only a release candidate, so we're very, very early into seeing how exactly Docker Swarm will look like in the long term. All right, and then the web UI you can get from Docker and Docker Cloud, but I'm sure there's going to be a lot of tooling around it. All right, Nomad. So Nomad was developed by HashiCorp. This is the same guys who did Vagrant, Consul and Terraform, among other things. They have a really nice vision of how software should be developed. Their focus is always to build software that solves one problem. So to translate that to my talk, they're looking to solve a single problem with a very low essential complexity and really just focus on one thing. So Nomad only does cluster management and scheduling only. So it doesn't do the 8 other things that Kubernetes or other managers do. It's very, very simple to operate. It's a single binary. It's written in Go, so it's a single binary. It's a single file. Doesn't matter if it's a server agent, a server or a client, just one binary. And then their philosophy is that you should compose services if you need, for instance, if you need service discovery, it integrates really nicely with Consul. So of course, HashiCorp, like all other companies, want you to use all their shit, including Consul, and as you'll see, some of their pieces of software that they actually sell for money. Because, of course, open source development doesn't make you money. Nomad is special that it doesn't only run containers, but it can actually run virtual machines. So you can actually talk to a virtual machine, I forgot the word. So it can spin up whole virtual machines, and can also start containers, but could even start a single binary. So that kind of makes it a little bit more flexible in terms of what kind of tasks, what kind of processes it can run. Doesn't have built-in load balancing. It focuses on one thing. But actually, there's a project called Fabio from eBay, which is super amazing. We've tried it out. I've seen the demo at HashiConf, but we've actually tried it out, and it really works really nicely, and it allows a lot of good patterns like I don't know, blue-green deployment, and many fancy ways of deploying software. All right, Nomad doesn't do auto scaling, so whatever resource you have is what you're running, and then persistent volumes, which is very tricky because now your container could be running anywhere, and then sort of how do you mount the data volume that container needs? It's a tricky problem. So Nomad does not have a solution, but it's on the roadmap. But really, the little bit scary part about Nomad is that they know all about the missing features. There are GitHub issues for it, and usually they are on the roadmap, and they're on the roadmap of Atlas, which is this beautiful web UI, which costs a shitload of money. Of course, HashiCorp raised $25 million a day before HashiConf, and they announced it, and now they need to make money themselves. So it's like, I don't know, it used to be like $10 per node or $20. So it was quite expensive. We'll see where that goes. All right, and then yeah, absolutely. That's a good question. Networking is console. The service discovery is console-based. Networking is. Tommy, help me out.
It's not really anything. It just no, it doesn't mean anything. Actually, you just use console and it points to the right machine.
Yeah. So. So you have the individual machines with their own IP addresses. I think I can answer now. The container will run on a random high port, whatever it runs, but it will be the service will be registered in console. So and then in console you actually have not just the address, which will just be an IP address, but even the port. So you can actually run many of the same things on the. Does that answer your question? Let's look at it after, okay, in the break or something. But yeah, it doesn't do any magic, that's for sure, because Kubernetes does. And maybe that's why you were asking. So Google developed it based on Borg. Borg is sort of all the smartness that they achieved the 60% with, and now it's maintained and managed by the Cloud Native Computing Foundation, which sounds very fancy, but it still feels Google to me. And it's extremely feature-rich. So it's actually doing a lot more than what we talked about. It keeps secrets for you, and does a lot more. It consists of many loosely coupled components. So the driving design decisions that the Kubernetes team made was that I'm going to write these separate pieces of software. They're either APIs or services, and they should talk to each other, but they should be loosely coupled. Maybe I care about one, but not the other. And this makes it operationally more complex. If you have a distributed system, it's just going to be more complex. So whereas Nomad is a single agent, here you have 5, 6 things like an API server and a kubelet and a kubeproxy and other services working together. So it's actually harder to really understand how it works, but it has an extremely active community and very good documentation. So it's not impossible, but it's definitely meant for more problems. Yeah, that's exactly what I said. It uses etcd as an external store, so that's another thing you have to maintain and run. Another reason, if you don't need cluster manager, you don't want to operate all these things. It actually has a conceptually very simple networking model that every pod gets its own IP address. Essentially, it's a virtual IP. It's fake, but Kubernetes will be able to use to connect the pods with each other. And if you actually have 2 containers running in the same pod, they can see each other over localhost. So it actually does more than it does not do a full isolation within this concept called pod, but you can actually have services being able to talk to each other through the network, the local network, or by other means. It shares volumes. It shares different namespaces. All right. It is more feature-rich. It's 1.3 now, I believe, and 1.0 was a couple months ago. So it really is more mature. some of the features that Kubernetes already has is auto-scaling and persistent volumes. And we found that the documentation is really, really great. There's a lot of great tooling around it. All the projects are open source, and there's no Atlas or Docker Cloud or really a sort of a tool that you need to pay for if you want to use it. It's Kubernetes. Take it and run it yourself. It will be slightly harder, but it's gonna be all the features that you need. All right, it actually has the built-in web UI. All right, and then there are many others. Obviously, I'm not going to go into these. First one, I believe Prezi is doing. Second one, we're doing right now at SSP. And then the third one is a very, very similar tool. It just uses Amazon services to achieve everything we talked about. CoreOS is a big player in this space, although CoreOS is using more and more Kubernetes. And Mesos and Marathon have been around for a long time. Airbnb runs on those platforms. And there's a company behind Mesos called Mesosphere. They raise money, so they now need to make money. You see the pattern? That's why you shouldn't raise money. But Mesosphere sort of calls their data center operating system, and that's how they think about it. And they really want to solve every single problem that is out there in your data center. And maybe that's a lot of accidental complexity. All right, so every solution that you've heard about and you see on a list solves a different set of problems. And there's supposedly this quote from Albert Einstein that says, like, everything should be made as simple as possible, but not simpler. I've actually read about this. Probably he didn't say it, but it's attributed to him. So what Albert was trying to say is that you should get rid of accidental complexity and keep essential complexity. Cool. And actually, I have one more slide. I thought it was over. So which one to use if I really had to make a recommendation for all of you? I would wait for Docker Swarm if you want to use your existing familiar technology and really don't want to sort of bring in a new moving pace. I don't believe Docker Swarm is stable and production ready yet. Use Nomad if you want something extremely simple that you want to schedule run tasks with, workloads with, and then use Kubernetes if you want a feature-rich and mature platform with a large community and adoption. And the reason I've underlined that every single time you make a technology decision, that should be true. If you're the only one using a technology, you'll be in pain because you won't know who to talk to. So I do recommend, out of the list, Kubernetes is probably the most viable solution today. But gotta watch all the videos I've linked and gotta try them all. Cool, thanks. And yeah, if you have any questions, then. Yeah.
Don't you think that the swarm is just adding unnecessary complexity to Docker?
Can you repeat the question?
Don't you think that swarm is just adding unnecessary complexity to Docker?
Not necessarily, because you have a feature set of Docker. So if all you have is Docker 112 on your machine, and you only use it to build images and run the same image in CI, let's say, or just a dev environment, then you will not touch Swarm. You will not use that feature set.
What if I don't need the DNS?
When you run a Docker daemon in standalone mode, all of those features are turned off. So you need to bootstrap a Swarm cluster, and then they become Swarm nodes. So when I'm on this machine and I do, like, I don't know, Docker PS, I'm not running in Swarm mode. So I could do like Docker node list, and it says like this node is not a Swarm manager, and I'm running. So I think those features are there but are not used, and you turn them on when you need them. It is the same Docker, so in some ways, yes, it does some complexity, but you don't need to use it. I think the reason it's good that it's done this way, because it really works well with the other features. So if you know how to link two containers in your own machine, that will work exactly the same in a Docker Swarm cluster. If you know how to create an overlay network that kind of like ends up containers being able to talk to each other, it's going to work the same way on a Docker Swarm cluster as well. So that kind of compatibility, I think, is useful. And it's the exact same API. So all the tools that work with a standalone Docker daemon work with a Swarm daemon. Yeah.
Have you just said that you use Empire currently?
Yeah.
Then your plans to migrate to some of these?
Yeah, I mean, to make a fair comparison, we use ECS. So ECS is Elastic Container Service, and it is a scheduler. It's a very stupid one, but it does what it is supposed to do. And if you look at our charts, our ECS clusters are actually running with higher utilization. So yay, we're saving money. But we really want to get that further up. So there are services that should be running on all the same machines. ECS is a very typical Amazon service where you have a lot of lock-in, very proprietary APIs. Not everything's open source, but they do a lot of things for you. You don't need to care about ELBs. Like ECS works really well with Amazon. So if your infrastructure is on Amazon, ECS will always have advantages. One last question, because I kind of ran out of time. All right, if
Just a quick one.
Yeah. Then the question would be, what kind of prototypes, proof of concepts have you done with others, and currently are you waiting for Swarm to reach it?
No, this is happening right now. We have a Google spreadsheet with all the pros and cons, and you can ask Tommy a lot about this project that we had. We tried out Nomad and Kubernetes. Docker Swarm we might try out, but it's pretty early. It's clear that it's pretty early, and our goal is to migrate to one of those. So we're planning to migrate off of ECS, and yeah. So we will migrate to one of those. We'll make the decision. I don't know, next Monday. Cool. All right. And I'm glad you asked whether we're looking for someone. So we actually have a platform engineer role that works with these exact technologies and topics, and we're dire in need of someone who can help us with this. Thanks, everyone.